Welcome to the lab for Module 5. Here we will get a hands-on experience with time series modeling using recurrence, and the recurrent cells that we'll be using would be the LSTM blocks that we have talked during the video lectures. Let's get started. So I have the code here in this folder, edX, and you can see all my labs are here. What I'm going to do now is I have activated the environment here using source activate cntk-pi35 on Linux or activate cntk-pi35 on Windows. And then I'm going to launch my Jupyter environment. And if you're using the Azure environment, Azure notebooks, then it would be simply launching those notebooks in the Azure Notebook portal. And we are going to use the Lab 5 here. We will walk you through time series predictions with LSTMs. We'll use the same IoT data from the solar panel example that we have been using in our lectures. So this is the solar panel that we are using for our exemplar data set. Each of these solar panels emit how much electricity they are generating on a periodical basis. However, you'll see that not always all the panels would record what they are generating. So we have to deal with some missing data, and which is part of the data set here. So we have recordings from the solar panel on a half-hourly basis, and we also know the total output of the solar panel for a given day. So in this lab, what we will do is walk you through the following steps. Setup you're already familiar with by now, so we'll not go into it too much. We'll talk a little bit about data generation. A lot of time can be spent in data generation when you are dealing with machine learning and deep learning. So it's good to understand what the data looks like and how you want to process that before you want to start modeling. With the processed data, we are going to start modeling our LSTM network and then conclude the lab with the train, test, and prediction workflow. We import different components, different packages from the Python, and in the different packages in the Python environment. Pandas in particular, we will be using it. I'll point you to it when we get to that particular part of the lab. And we import CNTK. Here are some of the code that is used for testing these notebooks and is not particularly relevant for the lab, but we just ignore this for the moment. We ensure here that the environment that you are running is using the CNTK's released version 2.0. This notebook actually takes a fair bit of computation, and to let us run this notebook in a relatively quick time frame, we set this flag to be true. However, I would encourage you to also try out by setting this flag false and see how much difference you see at the end of the runs between the fast mode and the fast mode being set to true and the fast mode set to false. Let's take a look at the data generation. So you have solar panel, which emits two measures at 30-minute interval. We have the solar.current, which is the reported value of current produced by the solar panel. And solar.total is the total produced for the day in watts per hour. So here what you see is at 7 a.m. the solar.current reading and the solar.total. And you have a series of these values reported in your IoT data that is streaming from those solar panels. What we do then is we start to process the data, pre-process this in such a way that we can then use it for modeling. We read data into Pandas data frame, and I do recommend using Pandas data frame for doing a lot of reading of data that can be read in chunks, and you want to process them. It is a convenient package that allows you to process the data very efficiently and saves you a lot of time. We'll then normalize the data. Remember, in the MNIST data, we had scaled the digits between 0 and 1. Similarly, here, we are going to normalize the data within a 0 to 1 range. Then we want to group the data by the day. And finally, we want to append the columns solar.current.max and solar.total.max and generate the sequence for each day. Now let's see what those sequences look like. So the measurements for a day are grouped into a set of sequences like shown here, and each of them corresponds to the measurement for a day. So in here you can see these are the two readings that are available to us, and the total that was generated for that particular day is 10,300. As more and more recordings come in from that particular solar panel for a given day, you can see that more and more readings are getting accumulated, but the output of the solar panel, total output from the solar panel remains the same. Remember, some of these readings may be missing or may not be available because the solar panel didn't report those readings for that particular time point, and we have to deal with those kind of situations. Now, our sequence would be one of these instances here. For instance, there would be some anywhere between 8 to 14 recordings in our data set when we have finally processed it and cleansed it, and the corresponding, so that would be the X, the input, and the Y would be the total current that is generated by the solar panel for that particular day. Now, why I said 8 to 14 is that if we have less than 8 data points for any particular day, then we skip that data point altogether, because it's very unpredictable and what's going on it is very unpredictable what is going on that particular day, and it could be that many of the solar panels stop functioning and stop reporting. So that would lead to a different workflow if you were to build an application where you would send an alert saying that you have fewer than 8 data points being recorded. So there might be something that is going on. Either the solar panel is flaky or something's gone wrong. And if we get more than 14 data points, we are also truncating it in this case, because we feel that 14 data points is more than adequate for us to be able to predict what the output of the solar panel would be for that particular day. These data sets are available in a comma-separated value file. And what we do here in this function, the function generate _solar_ data. We take the URL as an input where the data lies, and here you can see that it's solar.csv. Once you run the notebook, you will be able to see where it's downloaded. Let's see. So in this case, my data should have been downloaded because I've already run the notebook. And you can see under the IoT folder here, I have that solar.csv file. You can investigate that file, what's in there, and understand what is the input to this pre-processing function. We use the pandas read CSV functionality to read the data, and then we do a normalization like I was talking about. This is important for our models to function well, where we compress the data into a range of 0 to 1. And then we group the data by the day or for a given date. Once we have these sequences collated, that becomes our input here, X, and the corresponding Y. Let me draw it here. So this becomes our X, and this becomes Y.